Bismillahirrahmanirrahim. Assalamu alaikum dear students. This is your instructor Ms. Saida Sidra from Department of Chemistry. Today this lecture will be the last lecture from solids chapter. In previous lecture we have discussed in detail about the allotropes of oxygen, sulfur, crystal lattice and different types of packing arrangement in crystalline solids. In today's lecture, we will discuss different topics. For example, the factors affecting the shape of an ionic solid, the comparison between ionic and covalent solids, and the comparison between molecular and metallic solids. So starting with the first topic, the factors that affect the shape of an ionic solid. Basically, there are three factors which affect the shape of an ionic solid. The first factor we have electrostatic force of attractions. Ionic solids are basically composed of cations and anions. They are held together by a strong force of attractions, and these forces of attractions they are responsible for their definite shape. Due to these forces of attraction, they have definite geometric shape. The example which we discuss here, we will discuss the example of sodium chloride. In this, the sodium loses one electron to form sodium plus 1 ions, means that by the loss of one electron from the sodium, it results in the formation of sodium cation. And the chlorine, it gains one electron to form Cl-1 ion. It results in the formation of chloride ion. The electron which is lost from the sodium is gained by this chlorine and leads to the formation of this chloride ion. So this is sodium cation and this is chloride anion. Both these cations and anions, they combine together and we will have the formation of what? Sodium chloride. And these ions, they combine together due to the strong electrostatic forces. And the combination of this sodium and chloride ions leading to the formation of sodium chloride, it is an exothermic reaction. As we have seen in previous lecture that in the crystal lattice of this sodium chloride, each sodium ion is surrounded by 6 chloride ions, means the coordination number of sodium is 6, and also each chloride ion is surrounded by 6 sodium ions, and the coordination number of this chloride is also 6. So, due to the combination of sodium and chloride ions, the cubic structure of sodium chloride is formed. And it is an exothermic reaction, and the delta H for this reaction, it is minus 787 kilojoule per mole. The second factor which affects the shape of an ionic solid is the radius ratio. The structure and the shape of ionic solid, it depends upon the radius ratio. For example, sodium chloride and cesium fluoride have the different geometry because the radius ratio for both of these compounds is different. What is radius ratio? We can calculate the radius ratio by using this formula. Radius ratio is equals to radius of cation divided by radius of anion. So by determining the radius ratio, we can determine the structure and shape of ionic solids. Let's have a look at this table given in your book that depending upon the different radius ratios, you can locate the different shapes of ionic solids. If we have body-centered cubic ionic solid, its radius ratio is 0.732 or above this value. If we have an octahedral structure, so its radius ratio lies between 0.414 to 0.732. If we have tetrahedral arrangement, then its radius ratio lies between 0.22 to 0.414. And if we have triangular arrangement, then its radius ratio it lies between 0.15 to 0.22. This r plus 1 it is the radius of cation and r minus 1 it is the radius of anion. We have different examples also. The radius ratio of following ionic crystals. Sodium chloride is having 0.522 radius ratio for the octahedral arrangement. We have seen in last lecture that each sodium ion is surrounded by 6 chloride ion giving an octahedral structure. And in the same way, each chloride ion is surrounded by 6 sodium ion giving an octahedral arrangement. If we have cesium chloride, its radius ratio is 0.93 for body-centered cubic arrangement. And zinc sulfide we have 0.40, it's having tetrahedral arrangement. So, depending upon this radius ratio, we can determine the structure and shape of ionic solids. The third factor which affects the ionic solid is their conductivity. They are poor conductor of electricity. They don't conduct electricity in their solid state. But when solvent is added, like for example when water is added, the crystal lattice is broken and the ionic solid changes into their respective cations and anions. Why crystal lattice is broken? The crystal lattice is broken due to the high dielectric constant of water. Just have a look at the example of sodium chloride. When sodium chloride it dissolves in water, it dissociates into its respective ions, sodium ions and chloride ions. In this solid form, this sodium chloride is poor conductor of electricity. But when it is converted into its respective ions, now these ions they are responsible for conductance of electricity. We can say this thing that ionic solids they are non-conductor in their solid state, but when they are present in their molten states, they are conductor of electricity. Now these ions they are solvated. Due to their solvation, they can conduct electricity. So these are the three factors which affect the shape of ionic solids: electrostatic forces of attraction, radius ratio and poor conductivity. The next topic which we will discuss is the lattice energy. It can be defined on the basis of different types of chemical reaction. What type of chemical reactions? Means whether the reaction is exothermic or endothermic. If the reaction is exothermic, so lattice energy it can be defined in this way, that the amount of heat or energy released when gaseous ions of opposite charges they combine to give 1 mole of a crystalline ionic compound. In exothermic reaction, energy is always released, while in endothermic reaction, energy is absorbed. So, how we can define this lattice energy? The amount of energy or heat released when gaseous ions of opposite charges they combine together to give 1 mole of an crystalline ionic compound. For example, the reaction we have the sodium ions in their gaseous state when they combine with the chloride ions in their gaseous state, and they both have the opposite charges. Sodium is having +1 while this chloride is having -1. They combine together and we will have the formation of word sodium chloride, which is a crystalline ionic compound. And the delta H for this reaction is -787 kJ per mole. This minus sign is indicating that this reaction is exothermic. If we define the lattice energy in terms of endothermic reaction, so what will be the definition of lattice energy? the amount of energy required to break 1 mole of crystal lattice into its gaseous ions. So the reaction we have that this is the opposite reaction, that when the amount of energy required to break this solid, this crystalline solid into its respective gaseous ion, that if we have crystalline ionic solid, crystalline sodium chloride, and it is converted into its respective ions in their gaseous state. So the delta H for this reaction, it will be plus 787 kilojoule per mole. The values, they are equivalent. Here we have 787, here we have 787, but the signs are opposite. In one reaction, this amount of energy is released, while in another reaction, this amount of energy is absorbed by the crystalline solid for its conversion into its respective gaseous ions. Lattice energy basically depends upon two factors. It depends upon the size and the charge of the ion. It decreases with an increase in size of an ion, means it is inversely proportional to the size of ion. If size of an ion increases, lattice energy decreases. If size of an ion decreases, then lattice energy increases. While it increases with an increasing ionic charge. It is directly proportional to the charge of the ion. When charge increases, lattice energy increases. When charge decreases, lattice energy decreases. Next we have the comparison between ionic and covalent crystals. You can write the comparison between both of these in this way, that first you can write the property in which they both are differ from each other, and then you can write the respective characteristics. The first we have the definition. Ionic crystals, they are basically formed due to the transfer of electrons to one another. For example, sodium chloride, we have discussed earlier also, and they are held together by the electrostatic forces of attractions. While the covalent crystals, they are the crystalline solids in which atoms of similar or dissimilar elements, they are held together in a network of single bond. For example, we have diamond. How their formation takes place? Again, we will take the example of sodium chloride. It's very simple, that sodium loses one electron and we will have the formation of what? Sodium cation, and that electron which is lost by this sodium is gained by this chlorine, and we will have the formation of this chloride ion. And both these cations and anion, they are combined together due to the strong force of attraction, and we will have the formation of this ionic compound. In covalent crystals, they are basically of two types. When covalent bonds, they result in the formation of giant molecules. We will have the example of diamond and silicon carbide. And when second type we have, when atoms, they are joined together by sharing of electrons. So in this type, separate layers will be formed. For example, graphite. The third property we have conductance. Ionic crystals, they are non-conductor in their solid state, while they are conductor in molten state. While covalent crystals, they are poor conductor except graphite. And if you remember this thing that we have discussed in one of the property of crystalline solids and isotropy, that also this graphite, it is conductor in one direction while it is non-conductor in the other direction. The fourth property we have geometric shape. Ionic crystals, they have the definite geometric shape. Covalent crystals, they have definite shape and they are also oriented in three directions and network structure. Fifth property we have directions. Ionic crystals, they are non-directional in nature, while covalent crystals, they have open structure, due to which the valences of atoms, they are directed in definite directions. Existence. Ionic crystals, they do not exist in the molecular form. They are non-molecular. While covalent crystals, they can exist in molecules due to their covalent nature. For example, we have S8, P4 and ice. These are the examples of the covalent crystal. So all these are the 6 different properties in which the ionic crystals and covalent crystals, they differ from each other. First we have defined both of these, then we have seen this thing that how both of these crystals they are formed, then conductance, geometric shape, direction and existence. Next topic given in your book is the low density and high heat of fusion of ice. First we will discuss about the low density of ice. If you remember, we have discussed this topic earlier also in liquids chapter, anomalous behavior of water. If we decrease the temperature, what happens? By decreasing the temperature, the molecules they come close to each other, and as a result of this, the intermolecular forces increases. But the case is different in water. As the temperature decreases from 4 degrees Celsius to 0 degrees Celsius. At 4 degrees Celsius, the hydrogen bonds present in water, they are randomly placed. But as we move from 4 degrees Celsius to 0 degrees Celsius, means when liquid changes into an ice, so empty spaces they develop in ice due to the hexagonal arrangement of hydrogen bonds in ice. There will be an increase in 9% spaces in an ice, means in turn the volume increases. So what does this increase in volume? It affects on its density. We are familiar with this thing that density is equal to mass by volume. If volume increases, then in turn density decreases. So due to this decrease in density of an ice, it floats over the water. And due to this low density, it has an important application in real life, that in cold regions, that this ice, it acts as an insulator. So the fish and the plants, they can survive for months under the blanket of ice. The second property we have, high heat of fusion. We have also explained this earlier in liquids chapter, that what is heat of fusion? That the amount of heat required to convert 1 mole of a solid into its liquid is called as what? Molar heat of fusion. This H2O solid means ice, H2O liquid means ice is converted into liquid water. And the delta H for this reaction is equals to 6.02 kilojoule per mole. What is its application in real life? That ice, it can absorb 333 joule of energy for every gram of ice to melt. If 33.3 kilojoule of energy is absorbed by the drink from surrounding, the temperature of the drink without ice would rise from 0 degrees Celsius to 20 degrees Celsius. This is without ice. But if we have an ice in drink, so what happens? The drink containing the ice, it remains at 0 degrees Celsius, but 100 gram of ice would melt. Means that ice, it results in the maintaining of the temperature of the drink at 0 degrees Celsius, but itself it will melt. So how much gram of ice would melt? 100 gram of ice would melt in order to maintain the temperature of the drink at 0 degree Celsius. The next topic we have the comparison of molecular and metallic solids. First we will discuss in detail both separately. We will discuss first molecular solids and then we will discuss in detail about the metallic solids, and at the end we will discuss their comparison. What are molecular solids? The solid substances in which the particles forming the solids, they are either polar or non-polar molecules, are called as what? Molecular crystals. The intermolecular forces present in molecular solids, there are two types of intermolecular forces. We have dipole-dipole interactions and van der Waals forces. Examples we have crystals with polar molecules. For example, we have ice and sugar. And crystals with non-polar molecules, we have iodine, sulfur, phosphorus, carbon dioxide, etc. What are the properties of molecular solids? The X-ray analysis, it has shown this thing, that the molecular solids, they have the regular arrangement of atoms. So due to this regular arrangement, all of the atoms, they are present in their exact position. Polar molecular crystals, they have higher melting point and boiling point than non-polar molecular crystals. Molecular solids, they are soft and easily compressible. They are volatile in nature. They are bad conductor of electricity, and they have low densities due to the weak attractive forces present in them. And the last property, they are transparent to the light. All these are the different properties of molecular solids. Next we have metallic solids. If we define the metallic solids, so these are the crystalline solids in which metal atoms, they are held together by metallic bonds. For example, we have sodium and copper. And what type of intermolecular forces which are responsible for this metallic bond? We have two types of intermolecular forces. First, we have forces of attraction between the electron gas and the positive ions. And second, we have the forces of repulsion between positively charged ions. Both of these forces, they are equal and opposite. So due to this, they counterbalance each other. And metal atom as a whole will be neutral. Metallic solids, they have different properties, like they are the best conductor of heat and electricity, they have lustrous surface, they are malleable and ductile, and they have high melting points. Next we will discuss the electron sea or electron gas theory. As we are familiar with this thing, the metals, they are the good conductor of electricity. Why they are good conductor of electricity? This is basically due to this thing, that the valence electron present in them, they are loosely bound. Due to this, they can move from one atom to the other. And due to this property, they can conduct electricity. The positively charged portion of the metallic atom is surrounded by the electrons. And these positively charged ions, they are immersed in the solution of these electrons. So such an environment is called as what? Electron gas or electron sea. Have a look at this figure. This is the electron sea model diagram. These are the positive ions from the metal, and this is the electronic cloud that doesn't belong to any one metal ion. This is the pool of electrons, sea of electron, in which the positive charge of the metal atoms, they are immersed. And due to this nature, the metals, they are the good conductor of electricity. Due to these free electrons, metals, they can conduct the electricity. Next we will discuss the comparison between molecular and metallic crystals. As we have discussed earlier that molecular crystal, these are the solid substances in which the particles forming the solids, they are either polar or non-polar molecules. We have discussed the examples, ice. And metallic solids, we have discussed these now, that the crystalline solids in which metal atoms, they are held together by metallic bond or known as metallic solids. The intermolecular forces in molecular crystals, we have two types: dipole-dipole interactions in case of polar molecules and London dispersion forces in case of non-polar molecules. While in metallic solids, we have electron gas theory. Electron sea is surrounding the positive ions. Molecular solids, they are the bad conductor of electricity because they don't have free electrons, while the metallic solids, they are the good conductor of electricity due to the presence of free electrons. Molecular crystals, they are not malleable and ductile, while metallic solids, they may be malleable and ductile. Next topic from this chapter, we have hygroscopic salts. Some salts, they can absorb moisture from the atmosphere. Such salts are called as hygroscopic salts. For example, we have calcium chloride .2H2O. This 2H2O, it indicates that it has absorbed the moisture from the atmosphere. And this absorption, it becomes maximum when there is humidity in the air. And the water molecule absorbs, they become the part of that crystal, and it is called as what? Water of crystallization. And such substances, they are called as what? Hydrates. Due to this absorption of water, the mass of this calcium chloride as a whole will increase. We have also discussed one more example, if you remember, copper sulfate. Copper sulfate, it is pentahydrated. So, due to the absorption of this water of crystallization, their mass also increases. And the last topic from this chapter, we have that how to get sodium chloride from saline solution. As we are familiar with this thing, that the saline water means what? Sodium chloride solution. It contains water along with certain impurities. So, how we can obtain the sodium chloride from saline solution? If saline solution is allowed to freeze in a freezing mixture of water, the impurities, they come up to the surface in the form of an ice at minus 3.4 degree Celsius, leaving behind the sodium chloride. So in this way, the ice and impurities, they can be removed from the surface and we can obtain this pure sodium chloride from the saline water. So this is the last topic from the solids chapter. The MCQs related to this chapter and the questions, reasoning questions from this chapter, all these will be uploaded on your portal. Take good care of yourself and Allah Hafiz.